Hello everyone, this is Gianfranco Ruggiero, Senior Product Manager here at Autoform, and today we are going to talk about smart factory in the sheet and metal stamping industry. Still today, I have to say, the sheet metal stamping industry faces a lot of issues and challenges, let's put it that way, especially when we talk about the production plants. They still face high unplanned downtime, high scrap rate, and other issues that lower basically the capability of the process, make the process itself more costly, and puts at risk the business of the company working in this field of industry. Digitalization is making a lot of progress in other field of industry. That's what it seems like. But still, in our field of application, seems to be struggling a little bit. But digitalization is just the first step to get to what we call smart factory, or the applications of the Industry 4.0 principles. What a smart factory means for the sheet metal stamping industry? It means that in the production plant, we have a system that is capable of understanding what's going on, basically, and find countermeasure to issues as they occurred, or even better, predict issues, so detect trends during production and adjust process parameter automatically to avoid them, basically. That's the only way to constantly deliver parts in time, in quality, all the time. Reduce cost, be sustainable, be flexible, and so on and so forth, right? But how do we get smart in a production plant? Well, we have to go through some steps. Digitalization is important, but then we have another step that it's also crucial. It's called the detection, right? We have sensor devices distributed along the press lines just to detect input data, material characteristics of the coils, lubrication, distribution, and so on, process parameters of the press line output. And these devices basically provide a lot of data that then we have to be able to, elaborate and basically create what is called digital process twin. Now, the question is, how do we build the digital process twin? Digital process twin, according to many, could be built just based on the measurements that we make in reality. For us, we think that most of the job instead needs to be done already during the engineering phase, which is the first thing that you do when you engineer the stamping process. When you engineer the stamping process, you have to keep in mind that you're not going to produce only one part, basically, but you're going to produce 100,000, maybe 200,000 of those parts. That means that you have to consider during the engineering phase what happens in reality and the variability that you're going to deal with once you are in reality. Characteristics of the material, mechanical characteristics, they are not going to be constant. They will change from coil to coil. You will use many coils, of course. Same thing I mentioned before, the lubrication amount and distribution along the coil or on the blank. And other process parameters, variabilities that you have to consider, you cannot neglect. So that, first of all, with the application of what we call a smart engineering approach, you can lower the occurrence of issues. So you already consider in advance, months before the tools are even built, that this is going to happen. Make your process as stable as possible in the digital world. And then you build the tools accordingly, and then you move to production. And in production, you have the data that you have created already in engineering that will help you understand what's going on in reality and make and find the countermeasure to issues since the first stroke of the press line. In doing that, you create what we call a physics-driven digital process twin. That, of course, has to be, cross-checked with reality, just because we do not simulate everything, right, in engineering. But this is the best data that you can start with. So the engineering plays a huge role in the whole stamping process. Engineer what can be built and build what has been engineered. That's the only way to get smart in a factory. Thank you.